Hello everyone, welcome back. It's day 13 of our 8-bit computer project on breadboards. I'm joined today by some of Embedded's incredible senior advisors. We have Jess Frazelle and Jide Akinyode. Of course, Jordan's back again, and we are in the debugging phase. For those of you who tuned in last week, we did kind of hit some roadblocks. So we're gonna be debugging that today. So Jess, Jordan, and Jide, and Jenna, all J's. Maybe y'all can give a quick recap, and just to make sure everyone knows, we are building this 8-bit computer from scratch on breadboards. We actually started this project while school was still in session in Robeson County, and we were building it with the 7th and 8th grade students over there. They are continuing to build that from home over the summer. And so they should be tuning in with us here or on YouTube. And so we make sure to post all of the videos on YouTube shortly after. And so, yeah, we're really excited. This is all in collaboration with the Mentor Project. And so we're really lucky to have this opportunity to teach y'all how to build a computer. So Jess, Jide, Jordan, take the mic. Give a quick recap of the roadblocks we ran into last week, and then we'll dive into debugging this.
Yeah, so we're working on our register. We already built the clock. We know that works, so that's good. And we were hooking everything up, power and ground to the new board. And we also have an extra set of LEDs that we're going to use to like view what we have on the bus and then also load things from the bus. And so basically, when we powered everything on and set to load data, it's not doing what we want. And so we need to debug where this is coming from. And I believe Jordan has a multimeter, and like we're gonna get into
Can y'all see it? Here it is.
watching the power flow.
Maybe I can slide this over so y'all can see it. How's that?
Yeah, we added the multimeter to our handy dandy toolkit. So that's there, and today will be Jenna's first day using the multimeter live.
I know, y'all. Don't judge. Thanks, Hannah, for liking my jacket. It actually says JB on it. Where? Oh, I don't know if y'all can see. So when my friend Liz and I went to Deer Valley, the only place I went during the pandemic, we went for a little outside hiking trip, and as a joke, we started calling Deer Valley Deer Ballet. And so actually the back of the jacket says Deer Ballet, and we wore these all around Deer Ballet, and people looked at us like we were weird, but it didn't matter. Anyway, let's keep going. Thanks, y'all.
So we had a couple theories on what was going on. I think
Okay.
Jide had one he was chatting about, so maybe we can have Jide and just start running point on that theory.
Awesome. Let's go.
All right.
Yes.
Go ahead, Jen. Go ahead.
Oh
Jen.
no, I was gonna say go ahead.
Yeah, I was going to check the clear signal on the 4-bit registers. So that is pin 15. Can you check?
Let me just make sure this angle's good here so y'all can see everything. Okay, how's that?
Good.
Okay. So, sorry, we're here somewhere?
Yes, either of those two registers.
Okay.
Let's see, check. Those should be connected together from pin 15 to pin 15.
Okay. Let's see. From here, sorry y'all, I'm gonna tilt this. Pin 15, so that should be, let me grab my tweezies.
I'm here as well.
Oh my
to jump in.
gosh!
Sorry, go ahead, Jenna.
Do what?
I'm here as well to jump in if you need me
Oh,
to
perfect.
add anything.
Okay, let's see, we've got... We have a very special viewer from USC who may or may not be launching his own Twitch stream on Friday. Britt, let's try to get the details on that. Yay! Watching the experts. We're a work in progress every day, you know that. Okay, let's see. So we should have 16 here, and so yeah, this yellow wire, I believe. I don't know. Let me get our closer view going. Okay, here we go. Can y'all see me? Oh. I believe this yellow jumper goes from 16 to 16.
Yeah, it looks like you have it in pin 15 on
it's
both of those.
50. Sorry, it's 15. Is it supposed to be 15?
Yes, yes it is. That's
Okay,
correct.
good.
Okay, and then that clear would also be tied to ground right now to enable to allow data to pass through the chip. Is that correct, Jess?
Yeah.
So what should we be checking out?
That portion looks good.
Be like a jumper from clear to ground, right?
And which pins are those?
15. They were 15.
Oh, those are the 15. 15? Oh, sorry, I'm echoing y'all. Allison, YTV, hey!
So if you look at the last chip in that stack up, you have a white wire that is also in pin 15 that is in ground.
Yes, that's correct.
Okay.
So we have, it's this wire right here. It's in 15, and then right there in ground.
Okay. Trying to think what else.
That's looking good so far.
And so right now we have both load and enable set to ground, right, Love?
I believe so. Those pins that you're seeing on Jenna's screen right now, those two that are coming out, those are both to ground, which is clear, and then load. And then Jenna, if you could show us the right-hand side of the board as well.
Over here?
Yes.
Let's see if it'll get in focus. Ah.
Yeah, there's a wire coming from the far right chip that's one of the ones we set up just for debugging.
Here, let me slide all this over.
Perfect. There's a lot going on, though. The board's getting pretty complex. It's so much more dramatic.
With the light?
So much more, with the light blinking. Yeah,
like,
so that wire is also going to ground. You can see it going to the ground right next to your hand there, that longer white wire that's coming through. So, Gita, to your question, that's I think that's enable. So enable's also going to ground. So all three of those configurable ones of clear, enable, and load are going to ground right now.
All right, anyone on chat? Any ideas? Help. Can y'all see this?
Totally.
Yeah, that's pin 19 is enable, right? Sorry, I'm just verifying.
Yeah, that's pin 19 there. Press Jenna if you could double check that's pin 19.
On which one? Oh, on this one?
Where does pin 19 go?
Pin.
Is that longer cable that's going to ground?
That's this white wire, right? It's going to ground.
Okay. So what happens if we set that? Oh, that should be fine. It should go to ground. Shit.
Language.
Sorry.
And Darren, are you still on here? So, Britt, let's make sure that we get Darren's Twitch profile so that we can post it on here so that everyone can watch his stream. It starts on Friday. And so we're going to make sure and be watching. No big deal. Darren Gray's going to get embarrassed now because he's too humble, but he was named Engineer of the Year. He is pretty incredible, and he is teaching some fascinating STEM projects to, I believe it's high school students, starting on Friday at 1:30 p.m. It's going to be awesome. And Darren, those of you who watched, we built a low-cost robotic manipulator with Darren on here. It was actually, I think, our first stream. And so, Britt, let's make sure that we get Darren's Twitch stream handle, and so we can pop it in here and make sure. First of all, follow Darren. Oh, it'll be under Dr._SC_STEM. So make sure y'all follow Darren, and Darren, I assume you'll have like your schedule up there, but make sure to follow his projects. We're gonna be on there too, watching and commenting and getting excited.
Yeah, so I think maybe what we should try next, I don't know if we've already tried this, but like where the clock is being connected from our clock to the register board, maybe putting the multimeter there to make sure that we're actually seeing stuff happen.
All right, where should we put it?
So I think that's pin 7 on the 4-bit is where the clock signal's coming in. Is that right?
Yes, perfect.
Hey Jordan, I might need you to come coach me through my first time using this.
Yeah, let me hop in there. Just a second.
Hi, everyone.
Y'all, Jordan's here. I'm gonna need more lighting. My poor eyes, even with my special glasses, I don't know that I can see this very well. Am I the only one who struggles to see these things? Okay, Jordan, where am I going?
So we're gonna turn the multimeter.
Oh, let's make sure
back
that y'all
on.
can see how this is happening, in case anyone's doing this for the first time as well. Okay.
So what we're gonna do is place the black end of the multimeter in ground.
Okay. Anywhere?
I would choose close to the power input.
So
where the grasshopper.
So we're going
comes
up
in.
and over here. And Jordan, I don't know if they can hear you, so I'll make sure. Can y'all hear what Jordan's saying? Uncle Nerdist, and is enable active high and load appropriate to be held low?
From what I know to that question, yeah. it
Jordan
is.
says from what I know, yes.
Yes.
Okay. So ground like here.
Yeah, so we're gonna go to ground near the power cable.
Okay.
And then we want to look at what's going to pin 7 on the 4-bit register.
On
The second orbit.
on this one.
Yeah, so it's the pins that are bridged with the yellow.
So that's
We want to see
like
it
here.
pulsate with the LED, basically.
Wait, is that right? Wait, 7. Sorry, 7 would be here, right?
The second one.
Oh, on this one.
Yeah.
Yeah, so
Like
7
here?
there.
And I'm supposed to.
Hold them in.
What's supposed to be happening?
It
We're
should
supposed to be
pulsating
seeing a
with the clock.
reading on the
No,
multimeter.
it's not.
Okay, so, oh wait, there we go.
I'm
Oh,
pushing
that
pretty
looks good.
firmly
You see
here.
it now.
Can y'all see actually, Jordan? Can you slide the multimeter over just a little bit so everyone can see the numbers?
Yeah.
There. C# Fritz, help.
Okay, so that's pretty good.
Yeah, I think that 3.3 volts is just the time.
The multimeter probably can't update fast enough with like the clock. But like, no, this is good. We're like getting something, which
Okay.
is what we want. Okay. Well, that ruins that theory.
Just, would it be helpful to go into manual mode on the clock and see if it jumps
Maybe,
to
yeah, let's do manual
Fine.
mode. That's smart. This is why we have those options, so we can
Alright.
debug these.
What we doing?
So let's
So
change
what's
the
the
clock
switch on the
to...
clock?
Or go
Okay.
ahead, Jess.
Here. We're gonna flip this switch.
Yeah.
And go ahead and test that by pushing
And
the
then
button.
put the
Sorry, Jordan, I
multimeter
can't hear you.
Go ahead and test that by pushing the button.
Oh,
But with the multimeter in.
yeah, there we go.
Yeah.
Yeah,
And now you'll want to do the same measurement you just did
with this button pushed or no?
while pressing that.
Yeah.
How do you do this? How many hands do people have typically when they do this? You only have so many hands.
I'll hop in to help.
I need Edward Scissorhands. Here, I'll hold the ground one.
Okay. I'll hold power. And what is the multimeter showing? It's 4.9. So the clock signal's coming through well.
Okay, so that's good.
Okay, we can take this out now.
If you take your hand off, I just want to see. Yeah, it's gonna go down. Okay. Well. Okay. I'm trying to think what else. So
Let go.
we're
Jen,
getting
if you could
power.
let go of the button.
Yeah, C# Fritz, I need those Squidward hands. 6 total. How do y'all do this? G-Day, Jess, Jordan. If you were doing this by yourself.
You probably have like clamps or something.
Okay. I was
Yeah,
like,
those are the tools.
Let go of the button.
Okay.
I just want to make sure the numbers go down. Yeah.
It only drops to 1.8. Is that sufficiently low? Oh, it's down to 0 now.
Yeah.
Sure.
I feel like it's just slow on the update, so that's fine. Okay, so that's fine.
So y'all would usually, Jordan, we need to get those things. I feel like I need like Edward Scissorhand situation with my tweezers and just be like, phew, phew. Like finger,
Okay,
like tweezers that come out of my finger. No.
Let's set both to high, both enable and load to high.
We can do that.
All right.
So this is load.
Mm-hmm.
We can change that to positive.
Yeah, so load is pin 9, right? We're doing.
Wait, that's not on pin 9. Oh, that is on pin 9, yeah.
Okay, I just want to make sure.
And I'm just
at
moving this to
I'm just
positive.
double checking everything.
Okay.
So that's in positive.
Yep. But we still have this. Should we turn this on?
And then
We can do it
enable
in
is
manual.
positive.
Jenna tweezer hands. Oh, sorry. Enable is
Enable
positive.
is positive too.
Oh, Jordan, which pin is enabled?
That is
19 on
this
the
one
big
here.
chip.
Ah, no, it's not. Let me move it. G-Day, sorry, you kind of walked into this catastrophe.
No, this is exciting. This is real life, I think.
That's true.
This is why we do this live.
But how about my wire coordination? I'm pretty proud of it.
Okay. So now kind of what I just want to test actually is just like on the chip itself with the multimeter, like are we getting power to that actual pin?
Which pins do you want to check, Jeff?
Just make sure.
9, the load pin of the second register.
Okay.
Pin 9, the load pin. Oh, this one?
Yeah, so Jenna, if you want to do ground,
Yep.
I'll get the other
Oh, I
side.
can do this actually. I have enough hands for this.
If you want that one there, and then you want to do 9.
Here?
Yeah, and make sure they're really firmly inserted. Yeah, so we're seeing 5 there too, Jeff.
That's good. And then the 19 one, the one in 19.
Okay.
Sorry.
That's okay. Don't
Making sure that,
apologize.
like there's nothing weird. At this point, I have no other ideas. Okay, so that's fine too. So what should happen is when we set now load from high to low, load being pin 9.
Yeah.
So pin 9 should be in ground. We should switch
Okay.
it back to ground.
Okay.
Do you need the clock active, Jeff?
Yeah, we're gonna press the clock in a second.
Okay.
That's low. Okay, cool. So now if we put the multimeter, where do I want to put it just to test? I mean, okay, so if we press the clock, does anything happen? Just to see. Okay, no. It should have done something.
I'm DJing right now.
Since the chip defaults to high, everything should have gone high.
Do you think the chip could be dead?
Like the actual chip itself.
Yeah.
Do we have extras?
We have the ones from the other boards. Like the
Ooh.
V and instruction register.
Maybe let's try replacing them. Oh, well, could we test how it's dead? I mean, I don't know.
Did we check power and ground to each one of the chips just to verify that those are correct?
Yeah.
We can double check right now.
Jordan, sorry, I can't hear you. We both have headphones on, and he's right there, and I'm like, what am I checking, G-Dave?
Okay, let's check power first. So on the 4-bit registers, that is pin 16. Pin 16 should be in the plus side of the breadboard.
Okay, yep, I think for both of those, that would be... Did anyone else notice that I was just DJing and flickering the lights like we were at a club or something? Am I so embarrassing?
Do you want to verify with the multimeter that we get 5 volts over there?
Yeah, that would be good, just in case.
Oh, and then, yeah. Darren asked, does the third board have power and ground?
The third board doesn't need power because like we're getting power from the actual like wires that are coming over from the other board. For the LEDs, it's just LEDs that go into the ground.
So is
You do need a return though, so that is important to make sure
Yeah, you
you
need
have
ground, right?
are these
Yep.
supposed to be in power?
that. Yes.
Okay,
But can you measure that whole 5-volt
yeah.
rail?
sure can.
So let's make sure we have 5 volts on that.
Okay. So I'm basically going from here to just pin 16.
Anywhere on that plus rail
Oh,
on that second
anywhere
board.
on plus. Right
Yep.
here? Yep.
Okay, now let's go to the chip directly. Make sure that has power, like you were going to do.
And this is where my vision gets me. Oh, yeah. That one. Is that good?
Okay.
Oh yeah.
And
Yep.
then let's try this one. Is that right? Yeah. Yep.
Okay, that's good.
Hmm.
Okay, let's look at on those same 4-bit registers, and let's just make sure that pin 1 and pin 8 are also tied to ground.
Okay. Should be. Let's see. I'm going to switch actually to this closer view. Yeah. I believe that's these. Can y'all see them underneath the. There's pin 1 to ground, and then pin 1 to ground. Yep. Those little green ones. Jordan's pacing.
This is a very intriguing problem.
It really is. It's very weird. I think maybe let's try replacing the chip. I mean, that would be nuts though, if it just like wasn't chip. Like, great. I mean,
Should we?
Would it be both chips? Like if one of the 4 bits was dead, wouldn't
yeah,
we
if
get
one
the
of
other
them
half to
was
light
it
up?
would affect it because like we kind of have them intertwined like that.
Darren's asking. Oh, sorry, y'all. Darren's asking what chips are we using?
They're in the spec sheet. Let me see. I can get the part number. It's 74LS173.
So what if we just disconnect one of the 4-bit registers and just pull it out of the board?
Is there a quick way
Want me to?
to test one of the 4 bits separately?
Sorry, Jordan, we can't hear you. Oh, y'all can.
No, the only thing I can think of it right now is that if one of the chips somehow was malfunction or damaged, it could be preventing either the clear signals from transitioning or any of these low signals from transitioning. So
Because they're all in there pretty well.
yeah, I don't know. I would suggest maybe pulling one of the chips out completely, just
Okay.
pulling it out of the breadboard, and then we can do the same test that Jess was suggesting.
Like one of these?
Yep.
Yeah, before we pull it, let's unplug the board.
Ah, okay. Let me just. Yeah, thank you, Darren. Darren said the same. He's like, disconnect power. There we go. What if the whole thing was like. Darren, actually, when Jordan was actually at my house practicing the project we did with you, I think we told you this when you visited the office. I may or may not have smelled smoke, and I was like, I'm sorry, what has happened? What had happened, Jordan? All right, let's see. Okay, so I'm removing this. Where am I going with this? Just gonna put it here. Do we have another one, Jordan? A replacement?
I think we have a bunch from the other board.
Okay.
Yeah, there's a tub with them on it.
Okay. Now, of course, I don't remember exactly where this was on there, so sorry, everybody. Okay. This is 4.
Yeah, we have another board that we could use just to check the chips. I'm trying to think
Is this
of
the
like
right
if
one?
that's. It would take a while to set up.
No. Let me just make sure I find it. I think this is the right one. Does that?
Yeah, one thing we could do is build up like the B register and test that one. And if they
Yeah.
both don't work, it'll at least be a data point, but it is a good chunk of work away to get the second board ready.
Does that look like the right one? Come on, focus.
That should be right. Does it say 74LS173 on there? Can't see it.
74L, yeah, 74LS173, yeah.
Perfect.
Okay, do y'all remember exactly where this was? Okay.
So the little dot like
Yep.
thing,
It's top.
goes towards the right.
Yep. I'm trying to remember though exactly was it one where this green jumper is? It's connected from 1, right?
So
just so I know where.
remember we connected pin 15 to pin 15 of both of these, so that might show you where you're gonna slot it in. You should have a little cable that's missing a.
That's right. And that was that the yellow one? I think. Wait, let me just see. That's 1. That's too close. Hold on. I believe it would be right. Hold on, y'all. I can't see anything.
I'm here too.
I believe that's correct right here. Let me just get this in here and then we can double check. Y'all. Oh. Y'all, I remember when I was putting these in the first time, they were not cooperating very well. I had to like adjust the. Let me. Here we go.
Yeah, if this doesn't work on the next episode, we should just test the chips individually, maybe? I don't know. As like an exercise? I don't know.
I'm trying not to damage it by adjusting these legs so that they actually will go where they're supposed to. Oh. Rats. I might have overdone it with that one. Hold on. Is it just me or is that strange?
It looks a little off kilter.
Yeah, it's a little weird. It's like hold on. These things are like very strange, see? They're like,
Oh yeah, they're a little off. Sometimes I lean it up against the table to make them all aligned.
here we go. Okay. Try this again. Okay, where is that the right one? Let's see. We'll go like this. Can you see that? Is that right? Nope, one over. Is that right? I think that's right. Yes. Okay. Is that right? That yellow one is in 15. And that one's in 1. I think that's correct.
So 15-15? Sweet.
Yeah, I think so.
Okay, so
Hope so.
we should set, let's just make sure before we plug it back in that both enable and load are set to high. So that's pin 19 and pin 9.
19. Are set to power?
Yeah.
Yeah, okay, that one's on power, and then pin 9 is on, like this one, I think is on ground. So let me put it to power. Okay. And then, yeah. Okay.
And then turn on the power.
Oh, something happened. Did y'all see that?
Yeah.
And
It's
then
good because like nothing's supposed to happen right now, so that's good.
we did have one flash here though. Did y'all see that?
Yeah, that might have just been some stray power going somewhere.
Okay.
So if we now bring load, which was pin 9, to low.
Okay. Okay.
And then pulsate the clock. They should have all it up.
Should we try? Maybe it's this one. Maybe it's this chip. Should we try replacing that one?
It could be.
Should we try?
One thing G-Day was suggesting was to build a little test circuit for each of the 4 bits. So we can verify the...
Oh, Jordan, your audio cut out. Sorry, Jordan, your audio cut out for me. That you were saying G-Day had a recommendation?
Oh, G-Day had a recommendation to build a little test circuit for the 4-bit registers so that we can figure out if they're behaving well.
Okay, let's do it.
G-Day, do you still think that's a good idea?
Well, I guess we kind of already have that set up. I'm trying to isolate failures in the circuit. So we know that each of the 4-bit registers themselves have their own output LED, right? And those get fed into the 8-bit register by themselves. So by removing one of the chips and then testing if the functionality is there, we can look at the moding side of the chip, so the enables and the load, which is what Jess was just suggesting. So since we have the circuit set up, we could remove each of the chips separately, test, and then we could remove the 8-bit chip and test by themselves.
Okay.
Jess, does that make sense?
Yeah, that sounds good.
And so, should we do that on this stream? Should we save that for next week? What do y'all think?
It is a whole exercise, so maybe we save that for next week.
That works for me. Oh, Darren, thank you so much for coming. Yes, we will see you on Friday. And yeah, he's going to be building a robot with his students. So y'all make sure you follow Darren and join him at 1:30 p.m. this Friday. Thanks, Darren, for coming. We're so excited. Okay, so y'all, why don't we pick up there next week? And does that sound good to y'all?
That sounds good to me.
Absolutely.
Okay. All right, y'all. And please, Britt, actually, let's send we need to get back to using our Jenna Learns Discord channel. And so, or what is it? What do you call them actually on Discord? Discord, what are they called? Y'all know what I'm thinking. Our server. And so please send any questions that you might have on this project there. Britt just put the link. And then we'll all be available to chat through things. If you're working on this at home and you have anything coming up that you want to talk through, just let us know. And also, we'll start putting more updates on there about what we're up to as a fund, what our advisors are up to. They're all doing incredible things. But thank you so much, Jess, G-Day, Jordan, for yet again teaching me new things alongside the 7th and 8th grade students in Robeson County, North Carolina. This was super fun.
Thanks, everyone.
All right. Thanks, y'all. Enjoy the rest of your week. Oh, and we'll see you next Wednesday at 11 o'clock a.m. Pacific. Thanks, y'all.